Hi everybody, I have a very simple point to make in this video. To find the output for a given input on a graph, just draw a vertical line, that means a line going up and down, through the input and see where it intersects with the graph. Okay, so for example, let's say we have this function y of x. So y is a function of x, and it is equal to x plus 2. So whatever x is, we just add 2 to find y. Okay, so for example, if x is -5, then we do -5 plus 2, and that's -3, so y would be -3. If x is -2, -2 plus 2 is 0. If x is 0, then 0 plus 2 is 2, and if x is 1, then 1 plus 2 is 3. So those are just some examples. The domain of x is all numbers, so x can take on any number. So really this table would have an infinite number of rows. I just gave you 4 over here. And we could plot those 4 points on the graph. So we have -5, -3. So when x is -5, y is -3, so that's right over here. When x is -2, y is 0. So when x is -2, then y, which this is y on the vertical axis, y is 0. Okay, then 0, 2. When x is 0, y is 2. When x is 1, y is 3. So I have 1 here for x and 3 for y. So you can see that these are in a line here. And of course, I didn't have to do just these 4 examples. I could have done -1.5, and then -1.5 plus 2 would be 1/2. So you can see that this is another point on the line, -1.5, 1/2. Okay, so actually there are an infinite number of points on this line. There are an infinite number of solutions to this equation, right, of picking 2 numbers, one for x, one for y, that would make this equation true. I just gave you 4 or 5 if you count the last example. Now, if let me just erase those. Okay, so now if I were to draw a vertical line through -5. So here on the x-axis, I see -5 is over here. If I were to draw a vertical line through that, then you can see it's going to intersect this line, which represents the function. It's going to intersect that line at this point over here, which is the point -3 on the y-axis. Okay? And which makes sense because -3 is the output for the input of -5. And if I were to draw a vertical line through -2, there's -2, I'm drawing a vertical line through it. It intersects this line at 0 for y. Okay, which again makes sense because when the input is -2, then 0 is the output. And we could do that for all of these other examples that I've been talking about. So over here, I see, so if I were to draw a vertical line over 0 on the x-axis, then it intersects this line at 2 on the y-axis. And the last example that we had was this one over here. If I draw a vertical line through 1, then it's going to intersect this line at exactly where the output for that input was, which was 3. Okay, so when the input is 1, the output is 3. Now, all this might seem obvious, but here's the real point, is that I mean, and it's obvious because I already gave you those values over here, right? So why did I need to draw the vertical lines to figure out what they were? We already knew what they were, and we have this equation over here. So even if I didn't have the graph, I could just plug any number I wanted to into the equation over here to tell me what y is based on what x is. So why do I need all of this with the vertical lines? Well, what if I gave you something like this? Now, I'm not telling you what the equation is, and I'm not giving you a table of values. I'm just telling you that this is the function, and based on this graph alone, if I were to give you an input, could you tell me what the output was? Well, now it's easier if we think about that vertical line strategy that we used before. If I tell you that the input is -2, what's the output for this function? Well, what I can do is I can just, here's -2. Let's again call this x and this y, or if we like y of x, okay, because y is a function of x. So what's the output if -2 is the input? I could draw a vertical line through -2, and it intersects this graph right over here at, let's just eyeball that, say that's about 2.5, okay? So I can start making my table of values over here based on drawing these vertical lines. So when x is -2, then y is equal to about 2.5, okay? And we could do that for anything. So what if I wanted to know the output for the input of 5? Well, I would draw a vertical line through 5 and see where it intersects the graph. And that looks to be at about, let me just draw a dotted line over here now. That looks to be about, I'll say -1.9. So when my input is 5, my output is -1.9. And you might be saying to yourself, well, does it really have to be, do you have to draw the whole vertical line? No, of course you don't. If I wanted to find the output for the input of -6, so if -6 is my input, I could just start at -6 and then go up to the graph here and then over, and that would be, let's call that, I don't know, about 1.3. So if the input is -6, clearly I'm not doing these in order here, but if the input is -6, then the output would be about 1.3, okay? So no, you don't have to draw the entire vertical line. I'm really telling you to draw the whole vertical line as a setup to my next video where we'll talk about something called the vertical line test. But the idea is just that if you want to draw this vertical line and see where it intersects the graph, then that tells you what the output would be for any given input. All right, that's it. Have a good day. Oops. There we go.